At integrals of these inverse trigonometric functions. So again, these are all in your book. You can get them from your book if you can't read my writing here. I tried to do the best I could. But integrals, so if you're integrating, for example, you notice that you have 1 over, or du can be in the numerator right here, it doesn't matter. Why isn't that working? There we go. So du can be in the numerator right here, it doesn't matter. So du or 1 all over the square root of a squared minus u squared. So a few things to remember here. First thing is that your a value has to be greater than 0. So a, okay, some constant value is greater than 0. And then also u has to be differentiable. So I'm just going to say u is differentiable. So u has to be differentiable. So all of these are true. So the integral there, you have inverse sine. So it's just the opposite of what we've done basically, with the addition of this little a part. Because usually this is 1, 1. But if it's, we're just saying if it's anything other than 1, fits into these patterns. So go ahead and jot these down, pause the video as you need, and then we're going to try some examples under here. So for the first one, we extend the page so we have plenty of room. So for the first one, you have the integral of dx over the square root of 4 minus x squared. Figure out what your a and u are. So in this case, it's a squared, so a is 2. And then your u, in this case, is just x. Because remember, it's a squared minus u squared, so it's 2 is a and u is x. So then that's the inverse sine, fits into that pattern for the inverse sine. So then the integral of that's going to be the inverse sine of x over 2. And then remember, it's indefinite, so you would need that plus c. Okay, go ahead and try the other one, see how you do. Looking at the second one, we're going to go ahead and figure out what your a and your u are. And in this case, your a is the square root of 2. So this one's tricky. Okay, this one's tricky. So this is a squared, and the square root of 2 squared is 2. And your u is just going to be 3, oops, not 3x squared, just 3x. Because right here, this is a squared plus u squared, and so 3x quantity squared is 9x squared. Now this is inverse tangent, so it's going to be 1 over a. So it's 1 over the square root of 2 times the inverse tangent of, you have your u over a. So it'd be the u over, so it'd be 3x over the square root of 2, then plus c. That's a 2. Okay, and then that would be the derivative of that. So on these, you just have to be careful. You have to recognize that, hey, if you have a square root in the denominator, it's possible. It's not always going to be that way. So we'll do some problems where it's not always that way. But it's possible that it's going to be one of these inverse trig functions. And in the bottom, if you have something squared plus or minus something squared, and it's possible it's going to be the inverse tangent or inverse cotangent. So now let's look at the last one. Okay, this looks like your inverse secant one, so figure out what your u is, and then, oops, yeah, figure out what your a is. And so this one's really tricky. We're going to have to manipulate this one a little bit, okay, because if you look at those rules up there, it's u times the square root of u squared minus a squared. And so this out here, oh, and then on top it's du, right? Yeah, so du. So now what we have to do is if I multiply the top and bottom by 2, that'll change it to 2. Whoops. This is a 2 times dx on top, all over to 2x times the square root of 4x squared minus 9. Now if you look at this, okay, your u in this case is going to be your 2x, okay, because it's u squared, so 2x squared gives you the 4x squared. That's why we had to make this 2x out here. So if we make this 2, we had to put a 2 up there. And then your a is 3. That's a 3. That's an ugly 3. It's hard to use this thing. Okay, then when we integrate, Okay, you know your u is 2x, your a is 3, so it's going to be fit into that inverse secant, so it's going to be 1/3, 1 over a, times the inverse secant of the absolute value of 2x over 3, and then we're going to squish in here the plus c. Okay, so again, with these, you just have to be able to recognize a pattern, see there's a pattern, and then figure out if you can do it by using substitution, or if it has to be one of these inverse trig functions. These are really tricky. Just be really careful as you go on and try some of these on the homework. Okay, so for this next one, you really have to be able to look at this and tell right away that you can't use regular substitution, because if u was anything, like if u was 2x, you're still not going to get rid of the e to the u minus to make it something similar to what we're used to, so it has to be an inverse trig function. So first of all, we have to get it to look like one of those properties. So again, you have to get these properties in your head to what they look like. And so in order for this to look like any of those properties that we just talked about, u has to be e to the x. Okay, so if that's true, then du is equal to e to the x dx, and so then dx is equal to du over e to the x. So we're going to have to do a little bit of u substitution there, and then when we do that, you'd end up with the integral of 1 over, now you're going to get rid of the dx and make it du over e to the x, and remember u is e to the x, so it's just going to be u, which is e to the x times the square root of, now e to the x is u, so e to the 2x is u squared, then you would have minus 1. Now that should look, times the du. That should look somewhat familiar. That's actually the identity for the inverse secant. So then when you plug that in, that's going to be the inverse secant. Remember, it's the absolute value of u over, in this case, 1 plus c. And then when you plug those values in, it'd be the inverse secant of e to the x, which is always positive, so we don't need the absolute value bars, over 1, and then plus c. And you don't necessarily need that over 1, but that's okay. And then you can just leave it like that. Alright, so let's go ahead and take a look at the next one. You're evaluating the x plus 2 all over the square root of 4 minus x squared, and now on this one, this isn't going to fit an identity, and you can't necessarily use your u substitution on all of it, because you can't really get rid of, even if you did use u substitution, you couldn't get rid of this x plus 2 by setting u equal to x squared or even 4 minus x squared. Not going to work. So you're going to have to split this up, and since you're adding the top, you can make it your first numerator over your common denominator plus the integral of your second numerator over your common denominator. Okay, so we'll say this is integral 1 and this is integral 2. So let's focus in first on integral 1. And on integral 1, this doesn't really match any of the identities. So we're going to use u substitution. So u is equal to 4 minus x squared. Then we're going to find du, so that'd be du is equal to negative 2x dx, and dx is equal to du over negative 2x. And then when we substitute those in, you'd have x over square root of u. Remember, your u is hardly ever the square root itself. Okay, very rare will that be the case. Times du over negative 2x. And those x's will cancel. And that 1/2 can come out front, so you'd have just negative 1/2 times the integral of just 1 over the square root of u, which is u to the negative 1/2. And then when you integrate, you would have then, come down here, negative 1/2 times the integral. So when you integrate that, you add 1. So that would be to the 1/2. So u to the 1/2 divided by 1/2. Okay, those will cancel, so you'd have just negative u to the 1/2, or negative square root of 4 minus x squared. Now, that was the first one. Now looking at the second one, so let's highlight this one. Now let's come back and, oh, look at that. Battery's dead. Gotta hurry. Been doing this a while. Alright, 2. So long story short, on the next one, it's actually a trigonometric identity. So if you factor the 2 out front, it should look familiar. You have the square root of 4 minus x squared. Okay, that's a trigonometric identity for inverse sine. So it's going to be 2 times the inverse sine of x over 2 plus c. And then that's our second part. I picked a crayon, darn it. Right there, and so we're going to put that with our first part, and when we do that, you would have the negative square root of 4 minus x squared plus 2 the inverse sine of x over 2 plus c, like that. Okay, let's go jump on to the next one, completing the square. So on this one, no current method that we know is going to work on this one, so there's got to be another way, and there is. So if we look at that bottom, you'd have x squared minus 4x. So you notice that you can take this, and since you have this, these are a difference of squares, or whatever, however you want to think of it. Alright, well, it looks like I'm going to have to stop here, and hopefully this will work when I continue on.